Okay, so seems it's live now. Okay, so yeah, not that much new that actually needs hardware demonstration today, so no webcam. Kitty. Mostly was working on debugging the hex and port to the ISA and stuff, but found a few compiler bugs and other things. So fix those. But it can be noted that the demo playback works a lot closer to correct. This being in the emulator, but so thus far demo playback works. It does diverge right at the end of the demo, but so at this point the player shouldn't be running into the wall, but it seems to be happening at the last few seconds, so it's not too bad. This has been fixed, so this part doesn't crash now. So, yeah, as can be noted, like, a lot of this is working a bit closer to how it's supposed to, so. Menus also now work. And this lava is still here for whatever reason. Not sure why they put lava on this map, but it's, kind of hidden. So yeah, teleporters and similar also work. I had discovered in the course of the past week that there was actually a decent number of bugs, or decent number of compiler bugs which were causing things to not work. For example, this water was all seriously glitching out because it turns out the precedent or operator precedence in the C parser was a bit wrong. Like some really old vestigial code had caused some of the operators to be in the wrong place. So due to the statements for the water scrolling not having a whole lot of parentheses, they were misparsing. Had also discovered that a lot of the ACS scripts were kind of messing up and crashing because basically for some operators like the double plus operator and your increment and decrement and similar, it was evaluating the left hand side twice, which was, you know, not correct in the case where the left hand side contained a mutable expression. So yeah, instead of, like, you know, evaluating the mutable expression once, it would evaluate it twice in the case of, you know, a simple plus plus operator, or it might evaluate it more times for more complex expressions. That was, of course, not correct, though. Yeah. So as can be noted, yeah, the ACS interpreter appears to be Yeah, the ACS interpreter appears to be mostly functional now. So yeah, that part's working. There are still some bugs. Still some bugs that I haven't resolved yet, but I have an area or an idea for where to look for that. As for performance, this is running it, emulating it at an unrealistically fast clock speed, so change it down to 50, see how it looks right now. It is still, well, pretty bad. But as noted, I haven't really been optimizing it or anything yet, so it's yeah, I haven't really been optimizing it or anything yet, so it's basically yeah, it's still pretty much unoptimized. kind of, this is, I sort of haven't switched out to, like, using a debug version that, sidestep the offending issue, but basically what it was is, in a lot of cases like this, well, not this one so much, but yeah, like this here, which still need to fix. Yeah, still need to fix this variant, but for like operators like plus equal, it might evaluate this side twice, which, because it has a mutable expression here, namely the double increment, it would effectively, as opposed to evaluating the target once with a single double increment, it would evaluate it with 2 double increments, which is obviously not correct. Maybe. I guess it's debatable how obvious it is, but in this case it's not correct, and in this case it rather than correctly running it once and then incrementing the target, would actually evaluate it once, take the value from one location, add 1 to it, and then end up storing it back to the next location, incrementing this pointer twice, which was, also not correct. But this is something I started trying to work on, but the logic isn't complete enough. It'd be moving the ternary operator to using a conditional select rather than branching, but that's a fix. So here's basically the change I made to the increment operators. Was, the old version would compile the expression, then it would compile the expression once, then it would duplicate the value, evaluate the plus or the plus plus operator over that value, and then store it back to the destination. That strategy of course fails if the expression t here is mutable. So happens is now it checks if it's a clean expression, aka one with no side effects, and if it is, then it more or less uses the old method, and if it's not, then it uses a new method which essentially compiles a reference to that expression, and then more or less, takes the value and then duplicates it, then increments one side, and then copies the index over, or copies the index, basically the reference again, to the top of the stack, and stores the modified value to that, and exchanges the 2 elements and pops it, and then yeah. The actual generated code doesn't do all this, but partly this is a side effect of me using a stack-oriented IR in this compiler. So it ends up with a lot of additional operations that actually disappear for the most part in the generated machine code. So these the duplicate operators and similar are actually end up just sort of moving around the register names for the temporary variables. So yeah, but so typically it'll end up just being a single temporary on the stack, or a single temporary variable, but it might get moved around and referenced multiple times on the stack in order to fit with a abstract stack machine. But yeah, the ones that actually generate something would be the stack reference, the load index, the increment, and then the store index. So that's would end up being possibly all three or more. Probably four or more instructions in this case. So yeah. In the case of a clean expression, it uses the original version because I tested it and confirmed that on average this version is actually faster for clean expressions. Yeah, faster and generates smaller code for clean expressions than this version down here. So overall this tends to be this still tends to be better, even though there's a potential it can be worse if the expression t is complicated, because here it's t is evaluated once, but here it's evaluated twice. There's already a special case for ref, which in this case basically means a variable name. So in this case, uses a special version that directly increments the named variable. Yeah. Yeah, so yeah. So looking, yeah, it's this version here, as can be seen, it still evaluates the left argument twice in the course of, well, of evaluating it and performing the operator. So I'm going to need to modify this. So in this case, care about ln, which is the operator for the left side, but yeah, rn doesn't matter because the right hand side is only evaluated once in this case, so don't need to make sure it's not evaluated twice. Can be noted that in this case I'm just using load index const with 0 as equivalent to a dereference operator, because that's basically how it's handled internally in this compiler. Yep. Sort of works under the assumption that, well, loading or storing index 0 and pointer dereference are basically equivalent. Oh. So yeah, in this case it's reference. Yeah, it loads a reference to the left side, duplicates it, then loads an index to get the value from the left hand side, and compiles the right hand expression to get the value, and then it does the operator, like say in addition. But of course, looks like in this case we want to make sure a copy of the value is left on stack, so duplicate the value again. Now we want a copy of the index, which is, well, somewhere different in the source file. But I was looking at it, so you can get it easily enough. So we have two values on the stack, and then the reference, or the first copy of the reference. This basically leaves the stack looking like so. Just call T1 the updated version of T, and so what it looks like after this up here, and we copy. So this would be index 0, 1, and 2. So then we copy 2, so that leaves it looking like that. And then we store. on. And so we store back to index 0, which takes off these top two, namely the value and the reference of the value, or reference. So you have the value in this item here. We just have to deal with that. So exchange the two items, which results in them looking like this, and then pop the top one, which leaves the value. Basically pointing out that yes, stack manipulation is fun. And since of course like a lot of this is also duplicated over here. Yeah, this one is basically expression forms of the thing, but this can be noted, well, not this one. Yeah, like these ones, they're not in the expression position, they're in a statement position. So we have this module over here, or this file over here, which does its own, copy of them, which is as notable. It does essentially the same thing, but it doesn't leave a copy on the stack. It's different. So in this case, what I can do, copy over the logic. But of course it's different now because this one doesn't need to leave a value on the stack, so change this. So don't need a duplicate copy of the value, and because it's not skipping over two items, it's only skipping over one item. We don't need that. And store back to that value. All we have now is just a reference, no duplicate value, so we don't need that, and we still need that. This, we can get rid of that because that's not valid anymore. And then save that file for good measure and rebuild the compiler and see if things are different. So note that right now it's 453,504 for the text size, but we'll see if it changes. Well, if something has happened, compiler has crashed. It means, yeah, it means it didn't like my one of my changes here. So is it this one? Or is it over to this side? What is my number for? So need to evaluate this. So yeah, so just seems to not like it for some reason, but don't see an obvious screw up in my logic. But compiler development is fun though in this way. And forgot to change this. See if it's breakpointing somewhere. Okay. Yeah, this is one of those things I've also tried fixing recently, or tried working on recently. So yeah, this is probably the first simulation pass, so it's probable I'm going to need to hack over this. Also, the fun thing about yeah, compiler development. But yeah, let's going on here is like basically most of the stuff in terms of 32-bit, like WEX operations, doesn't actually care about whether it's properly 32-bit aligned, except with one particular case, which is this instruction, which does a computed indirect branch, which actually requires the table of branches to be, well, properly aligned, and it checks that to make sure it is. But yeah, so what I was doing is I was setting a flag to tell the other code that when it begins a WEX section to make sure it's properly aligned first, but in this case it's actually getting invoked before it had a chance to go one pass through, so it's ending up with it being misaligned. So actually I don't need to add it over here because, well, I'm already looking at it over here. So just do it both cases with this. And that means if it's one of the first stage simulation passes, it will force it to be aligned, which in subsequent passes will, if it actually hits the flag, it will also cause it to be aligned, presumably. Time to test. Or 59, 168. Something has changed. Or 53, 504. So, yeah. This means the change in logic has increased the size of the binary by several kbytes. Not necessarily a good sign, but yeah. Actually, I have to get back here. Process of elimination. See, all is a change in size because of this logic, or because of the other logic related to the alignment. I have to test. It is due to the alignment logic. The reason the size of the text section is so relevant is because a lot of times if the size of the text section increases, it often, though not necessarily, indicates a sudden decrease in code generation efficiency, or something going horribly wrong, one of the two. But yeah, in this case it's due to the alignment logic, which is basically a little bit less of an issue. Just means that chances are padded some things out with knobs a little bit more or something. But now I can run it again and see if it doesn't crash, or see if it, if it works, or if it just completely blows up. The fun thing about compilers is, you don't always know if you're fixing a bug or introducing new ones. All you can really do is aggressively test things, and with luck, the number of bugs fixed is outweighing the number of new bugs introduced. Of course, switch it back to a faster speed because, we already know it's laggy. So, the next stage of this process is, well, go and change the logic that was, added as make it work logic back to something closer to the original logic. And do it for a lot of these because, coverage. Don't necessarily know which ones it's going to hit, and stuff. So So I've gone and changed all these lines back to what they were originally. Well, more or less, except I'm declaring a variable, but that shouldn't affect anything. So now what happens is we have all these, well, ones that don't declare a variable but just do the operator directly, and you know, now we see if it still works. So what could happen here is, well, either it works like it did before, or it you know, blows up or starts messing up. So far, so good. Yeah, this little bug is still here, but other than that, it's a case of so far so good. The next map works. Yeah. Now what this means is that the bug in question is basically fixed. So basically, yeah. Previously it would have messed up on the first demo, and the second demo would have straight up crashed because of the ACS code, well, seriously getting messed up. But in this case, it's, yeah, it's, you know, just confirming that I actually built it. But yeah, it's using the original versions of the code, or original versions of the statement with the logic that would have been repeated twice, and it's, you know, still working and not obviously screwing up, which means the bug has been fixed. Probably. Most likely.
Greetings, mortal. Are you ready to die?
funny was um, this weapon was actually a little bit more useful before I debugged or started this debugging effort, because a lot of these little ghosts were actually a lot more prone to go through the walls and you know, basically clear out everything. Whereas now they're kind of a lot more prone to being stopped by the walls, which is probably what they were supposed to be doing. Yeah, they're probably supposed to be generally being stopped by the walls, but it was a little bit more convenient when they are all going through everything and clearing out the map. So so far so good. So theoretically just picking up the first piece of the weapon I'm currently wielding. But, you know, never mind if I'm sequence breaking by, you know, having the weapon right at the start.
My servants can smell your blood, human.
So yeah, this weapon is basically like a rapid fire BFG in this sense, but fires faster, but chews through mana at roughly comparable speed. So yeah. technically another big sequence break, but maybe. Haven't really messed around with hexing enough recently to really remember the proper order to go through maps to, well, person could go and, you know, play through this game properly, but for debugging, yeah, sufficient. I think at this point I'm technically at the third hub or something, but yeah. Yeah, admittedly, actually, when I messed with, like, hex and, like, closer to properly before, well, I never really got that far, much past the first, like, much past the first 7 portals area, so, yeah, well, not exactly high-end, or not exactly high-end gamer cred, but, so yeah, most everything past, like, that stage has been, you know, a whole lot of no clip, or a whole lot of no clip and, like, full cheat codes and stuff, so, yeah. Actually, I think this portal might go back to the second hub, but I'll see. This is a bug that's still not really resolved. Is it basically yeah, bug that's not fully resolved as of yet. Is it technically it doesn't actually preserve the state of maps when leaving or re-entering them. So yeah, a person can't really like proceed through the maps properly right now anyways, because it doesn't save the intermediate, or doesn't save the intermediate saves, and thus doesn't remember what you've done on each map, which is actually kind of an important feature for Hexen to work correctly, is, well, that it remembers your map states. Because yeah, if it doesn't remember your map states, as soon as you leave and come back, everything's basically reset to initial states. So yeah. Yeah, that does point out, yeah, I didn't go to the third hub yet, rather just no-clipped into the second hub, or actually into a map that's an offshoot of the second hub, which is this one. I think this goes somewhere. Oh yeah. Could run around here.
My servants can smell your blood, human.
Okay, yeah, that's it. last time I messed around with the map, this map I got to that portal through a different path, so I was wondering like how I got to the same map, but now I haven't. Now I figured it out. Now where am I?
My servants can smell your blood, human.
Well, yeah, I guess that points out that as far as all that stuff goes, like stuff does seem to be more or less working, or working about as would or as well as it does with this bug fixed. So now it's find and fix other bugs. Preferably preferably without actually needing to, or without changing the code being compiled, because, you know, but, this is more a thing of, you know, isolating bugs. So one might go and, you know, change the code around to be all like, confirm that a bug exists, and then like, you know, try to figure out the cause of the bug and how to fix it, but then like, you know, change it back to what it was originally once the bug is fixed, because, you know, this code, it's supposed to work, and stuff. So generally want to, or ideally want to leave it in the form it was originally written, unless there's a good reason to do otherwise. This is basically a lot of the same deal. It's gone and basically modified lots of this code to try to fix variations on that particular issue. Now my little hacky workarounds aren't needed anymore, because, you know, it's fixed. Some of this code, if one thinks about it, is actually itself a legacy of my much earlier and or like the much earlier cruftier coding style of my younger self. Is yeah, or at least like an uglier and cruftier coding style of my younger self has completely hacked over to try to make it semi-efficient. Because originally when I wrote my compiler like well over a decade ago, I well, basically just sort of reused an XML DOM variant, which is, you know, kind of crappy. Actually, I didn't use it originally for the C compiler. It was actually copy pasted from my original PGB script VM, which was itself based on DOM. Sort of this amazing thought of, at the time, of basically my roughly high school age self was all like, yeah, you know what makes sense? It's all like reuse DOM, and then like, you know, put a parser on top of it, and a tree walker or tree walking logic, and, you know, call that an interpreter. And it was about as fast as one might expect from that. That was actually pretty short-lived, because even running like pretty trivial logic, it was painfully obvious that it was you know, extremely slow. So, the next version of that was, you know, I'd reused parts of a scheme VM that, I'd also written in my high school years, but, yeah, I mean, you know, slightly earlier, like, ninth grade and stuff as opposed to, like, 12th grade, but, so yeah, reused parts of the scheme interpreter and stuff, which was at least slightly more efficient, and then you know had hacked a bytecode interpreter onto that, and it's all like, yeah, it's faster now. But then like made my like C compiler after, or started working on my C compiler after that, being all like, well, you know, C kind of syntactically resembles JavaScript, or at least my rendition of JavaScript. So it's all like, didn't seem like too much big of a jump, but I was kind of seriously wrong on that front. But yeah. So yeah, wrote the C compiler, you know, with hacked up bits of those first two VMs and similar, and some then new logic to experiment with, you know, generating native code, which, you know, seemed like, or seemed good enough at the time, except like, in my at that point early 20s coding skills weren't really up to the challenge of, well, actually debugging something like that. So well, couldn't make my C compiler work when I was, you know, a lot younger, and ended up just focusing more on more incarnations of my BGB script language, which over the course of like, you know, another roughly decade and stuff, mutated into something more closely resembling like a C sharp and or a hybrid of C and C sharp and Java than it did to the language it started out as. But and then I started my CPU project, or started up my CPU project again, and you know, kind of dusted off my old C compiler code, and now I'm all like, yeah, I'm gonna make it work. And but first off, I'm all like messing with its original XML DOM based syntax trees, and all like, this still sucks. Compile times are terrible, and memory overhead is terrible. So I, you know, did some quick and dirty hacky stuff, like, you know, making it have these little hint things. That's, you know, not just looking up you know, a node named left, but it also, like, you know, uses a reference to a variable which keeps track of an index number for left, so it can, you know, use integer compares to, rather than like, you know, st or like string compares for looking up the nodes, and yeah, magically faster and stuff. But and it's technically no longer the original DOM API either, but, you know, just sort of you know, sort of my quick and dirty replacement, which actually happened a little bit earlier on. So yeah, forget which DOM I used originally, but it was some or another DOM, or DOM for C. something like that. Though in retrospect, DOM is possibly one of the worst options to use for a syntax tree for a language. You know, but at the time, like the options I was aware of were like, it as well as either use DOM or use S expressions, and both had their pros and cons. Later I realized, like, I could, use an object representation like, or similar to how you'd represent JSON, but like, in a C form and stuff, like, but that was actually generally a better option for ASTs, but I didn't really use it for my C compiler, and completely redesigning it to use an AST format that's just slightly better was not really worth it. So ugly hackery it was to make it work. And a few years later, and I'm at my stage now with a compiler that sort of works and has still some pretty serious lingering bugs, but despite some of these bugs, like this crap I was just messing with earlier, it still more or less seems to be working. Questions will be, will Doom still work? And did my binaries get smaller or bigger? Oh, slightly bigger, but no real notable net change from the last time I built. I think I'll run Doom 2 this time. okay, and Doom has crashed. Yeah, so what this means is, well, Doom has crashed, but it's with a memory corruption. This is, a trade-off of having modified the logic in Doom to be considerably more pedantic regarding, checking for heap corruptions. Is, they're a lot more prone to, well, being detected. In the past, like, a lot of these corruptions would go mostly unnoticed, and then they'd cause something else to crash. But now, like, if I have it set up to, more pedantically check the zone values and similar, almost as soon as something gets corrupted, it will trigger it to basically print and dump all the contents of the zone, and then terminate execution. So it's a pro versus con there. But trying to debug these crashes is kind of a total pain. See what Doom has to say about, or see what Doom 1 has to say about this. of course, like, just realized that these changes, they affect, things at the AST level, which basically means that unless I rebuild the C, cause the C library to be rebuilt, and these changes aren't going to propagate, so aren't going to fully propagate through the thing. So what I'm going to do is, well, and nothing changed in the compiler, but so I need to or probe the Doom file, so I could poke it so that everything will get rebuilt. So E67.312 is where it's at, so I will see where it's at in a moment. No change. Rebuild Hexen for good measure. See if it's, 459.008. $458.944, so something has changed. Means that, like, some of my changes, like, have propagated through the C library and will possibly changed, like, something hopefully for the better and not for the worse, but can never know with this stuff sometimes. I'm not sure, but I think something happened slightly differently in that demo. So yeah, nothing appears obviously different in these last two demos, at least not thus far. So yeah, this part seems to be about the same, but I think I saw something happen slightly different in the first demo. Though the ending, or where it ended up near the end, looked the same as where it did before. And normally if an action changed, it caused like stuff to happen differently. It would normally change when the player dies, which would consequently change the ending result of the demo, but yeah. Yeah. So this part's still the same, but the first part is just slightly different. It's curious. Basically, the way the enemies behaved was slightly different than in previous runs, which indicates that some of the changes have had an effect on enemy behavior, albeit not actually enough to affect how the demo plays out. Those little subtleties and behavior are more or less why a lot of these demos generally have the player freaking out and similar as well. It's because Doom's demo playback is highly dependent on determinism. So if something happens differently, like a player or an enemy behaves differently, and it's enough to affect how the player moves or other things like that, it will change it may completely change the sequence of events over the course of the demo. So but in that case, it was enough to it was basically enough to affect, like, you know, some subtleties of enemy behavior, but not enough to cause the actual demo to play out differently. Which is kind of an unusual case in that sense. not sure if that issue was, or if that was there before. Now it's back to hexen and see what hexen does. Since I rebuilt that as well, and this one did change size. So the bug right at the end is still the same. Something is going on the other screen. Just curious. But yeah, momentary distraction there. Yeah. Scenario in this case is basically to rebuild Quake, see if it does anything different. No, Quake's demos won't really be affected as much by you know, changing the logic, but yeah, or just, you know, verify it doesn't completely explode or something. Might as well make it go reasonably fast as well. investigation here, namely that I'm going to drop down the speed a bit, because frame rates seem to be a lot faster than or a lot higher than I'm expecting to be seeing right now, but I'll confirm at lower speed. If I've magically managed to improve or somewhat improve the performance of Quake, that would be useful. Simple answer is no, not really. It seemed like I might have somewhat improved the frame rate, but at least according to this, the frame rate is still pretty solidly in terrible territory. See what it looks like at 75 megahertz. Yes, other question is, how fast will my emulator actually feel like going? Crank it up. How does it feel about 700? And it held 700. Well, like 900. 900 is asking a bit much. So it's dropped. It's like can be seen here. It's dropped below real-time emulation. So down to 793. So 800 would be almost real-time. But what if I do 750, pushing it right on the edge of what it can do in real time right now? This is basically along the lines of what if I just, were able to somehow crank my BJX2 core up to roughly about the speed of a Raspberry Pi. But yeah. Lots of texture popping going on here. But that's mostly because of potentially misguided and heavy-handed attempts at optimizing this, but yeah. basic question is, will this map still crash? No, just hang out here for a moment. And, oh yeah. We'll see if this crashes in a moment. There's a particular crash that seems to happen on this map, at least in the past, and it's a mystery if I might have found, if, like, you know, I might have discovered whatever was causing this mysterious crash. But yeah, that's getting annoying. Yeah, basically, yeah. This particular, like, map, like, has a thing where if I go into this general area around here and generally hang out either for a while in game or in the menu, a lot of times, like, Quake will usually crash with a memory corruption. But but then again, I did fix some compiler bugs recently. It's always possible, like, one of the compiler bugs I fixed might have fixed whatever was causing the memory corruption. But maybe, maybe not. oddly, for whatever reason, it didn't really seem to be occurring on other maps, but this map and this particular area seem to be kind of prone to causing memory corruptions. So yeah. As for emulator performance, yeah, I can actually crank up the emulator fair bit. So right now it's emulating Quake as if the CPU core were running at about 750 megahertz. Can't really go too much higher than that because, well, emulation itself has a certain amount of overhead and stuff. So past about 750 megahertz, the emulation overhead is enough that it causes the emulation to drop below real time as it tries to basically, well, for like emulation below like the maximum it can do, what it'll do is basically it'll add up the clock cycles, and then when it's exceeding the number of clock cycles it's supposed to have executed in a given amount of, well, wall clock time, it'll actually throttle it down to maintain the intended operating speed. Whereas if the operating speed is faster than what it can do in real time, it'll, you know, not actually accumulate enough cycle or clock cycles to throttle, and it'll, you know, just start dropping below real time. And then again, it would be kind of impressive if, like, you know, an emulator that's not particularly designed to be blazingly fast managed to, like, you know, achieve like gigahertz emulation speeds, because, you know, that just mean it's like, you know, within a reasonably short throw of what the actual x86 CPU is falling off. Yeah, emulation isn't free though, so has to, you know, fake all this stuff like, you know, the memory management unit and memory map logic and all that other fun stuff. So yeah, that adds a certain amount of overhead. Give it a moment here, because it's It's looking like it's quite possibly not going to crash, but not been sitting here long enough to really be certain yet. Yep, I'm feeling inclined to think it's not going to crash right now. Aye. So, yeah, inclined to think it's possible I may have fixed that bug. guess the question is how fast will it go if I tell it not to use JIT? Otherwise. Okay, yeah, this is an example of what happens when it's emulating but somewhat below real time. It is trying to keep up with what speed I told it to run at, but it is so yeah, it's trying to, keep up with, that 700 megahertz speeds, but it's only pulling off about 270. So I tell it to use 250. Now it should keep up with real time. OBS seems to think I'm still streaming, but YouTube is not going. Yeah, holds up as at 250 megahertz in the, pure interpreter mode. So, interpreter mode, it enables some features like profiling and other stuff like that, and more accurate modeling for, like, the cache hierarchy and so on. That's enabled, but it does reduce the maximum performance it can emulate. But 250 megahertz is still like faster than real time for the hardware I'm, trying to emulate, so basically works. And it's probably reasonably decent for, something that's just using a plain C interpreter backend with a bunch of stuff stuck on it for trying to simulate, or for trying to, mimic the hardware behavior and so on, which also eats up clock cycles, but, yeah. But I'm gonna call it all for now.